All right, welcome to the Explainer. Today, we are diving deep into NVIDIA's incredible vision for something called physical AI. And look, this is way more than just smarter software. We're talking about giving intelligence an actual physical body and then setting it loose in the real world. So the big question is, how on earth do you teach a machine to handle all of our world's chaos safely? Let's get into it.
You know, for the longest time, AI has been stuck inside our computers, right? Just this sort of disembodied brain crunching numbers in a digital world. Well, that's all changing. Right now, we're watching AI break out of that digital box. It's literally growing a body.
So you can really think of this as the third great wave of AI. The first wave, that was perception AI, back around 2012. That's when we taught computers how to see. Then, a few years ago, we got generative AI, which gave them a voice, creativity, the ability to create stuff. And now we're here. The third wave, physical AI. This is where they learn to actually do things all on their own out here in the real world.
Okay, so what is a physical AI, really? Well, think of it as the brain inside a robot's body. It's the part that's constantly taking in information from its sensors, what it's seeing, what it's touching, and then making a decision. What do I do next? And then it actually acts on it, sending commands to its motors to move, to grab something, to interact with the world. It's basically the missing link, the bridge between a digital thought and a physical action.
But, and this is a huge but, actually making this happen runs into a massive problem, and it all comes down to data. See, it's not like training a language model where you can just scrape the entire internet for text. You can't just download the real world to teach a robot how to deal with all its complexities and, all the high-stakes situations. And the first part of that data problem is just the insane scale we're talking about. I mean, look at this number. By 2030, the US alone is expected to have 4 million unfilled manufacturing jobs. The need for robots is absolutely massive. But think about it, training millions of robots for millions of different, often dangerous jobs. The amount of data you need is, well, it's basically impossible to collect in the real world.
And the second part of the problem? It's the risk, plain and simple. I mean, when you're teaching an AI to drive a car or operate some massive piece of factory equipment, the stakes are just sky high. You can't just use the old fail and learn method like you would with a piece of software. A 1% failure rate might be okay for an app, but in the real world, that could be catastrophic. The real world is not a very forgiving place to learn.
So this leads us to the absolute core of the problem, right? How do you get these massive, gigantic piles of training data that a robot needs to handle a million different surprises without causing a single disaster along the way? How do you do it safely? How do you do it fast? Because trying to do it in the real world is just way too slow and, frankly, way too dangerous.
Well, NVIDIA's solution to this whole mess is, honestly, it's pretty brilliant. It's this elegant three-part system. And it's not just about what runs the robot. It's a complete ecosystem for creating the robot's brain from scratch.
Okay, so let's break down these three computers. First, you've got the computer for the body. That's the chip that's literally inside the robot running the show. Then you have the trainer. Think of this as the AI factory, a massive supercomputer that actually builds the AI brain. But the real magic, the most important piece of the puzzle, is the third one, the school. This is a simulation computer that builds an entire virtual world for the AI to learn in, safely.
And this virtual school, this is the total game changer. It's all built around a concept called the digital twin, and it runs on NVIDIA's Omniverse platform.
So what's a digital twin? It's pretty much what it sounds like. It's a physically perfect one-to-one virtual copy of a real place, a factory, a city, you name it. And it obeys all the same laws of physics. It's a digital sandbox where an AI can practice for millions, even billions of hours. It can face every weird, dangerous, once-in-a-lifetime scenario you can think of, all without ever touching a single thing in the real world.
So when you start with simulation like this, you create this incredible, powerful feedback loop. It's a virtuous cycle that just keeps getting better and better. We can think of it as a capability helix, a spiral of ever-increasing performance.
So here's how that helix works. Step 1, you run endless scenarios inside that digital twin. Step 2, all those simulations generate perfect synthetic data that's already labeled, which, by the way, is a massive headache in the real world. Step 3, you take all that beautiful clean data and use it to train a much smarter AI back in the AI factory. And finally, Step 4, you deploy that new improved brain into the physical robot. And then you just repeat. Every single loop makes the AI smarter and more capable.
And get this. This isn't some far-off sci-fi dream. It's already happening, right now, at every possible scale. You've got companies using digital twins to design better products. You have giants like BMW and TSMC using them to plan out their entire factories. And you even have it at the city scale, with companies like Nokia simulating entire 6G networks to optimize them. It's happening. So, this capability Helix, it gives us almost unlimited potential, right? It's an unbelievably powerful engine for creating physical AI. But what happens when you have a powerful engine with no steering wheel, no brakes? You get chaos. And that brings us to the next massive challenge: governance.
And this quote right here just nails the paradox we're facing. The more powerful we make these systems, the bigger the governance vacuum we create. It's like this whole blueprint tells us how to build an incredibly capable AI, but it says absolutely nothing about what it should do, or maybe more importantly, what it shouldn't do.
So, to fix this, the idea is you need a second helix running right alongside the first one. You need a governance helix to act as the steering wheel for the capability helix. And when you put them together, you get this double helix model. It's a complete blueprint that finally balances the how we do it with the what we should do.
Okay, so what's inside this governance helix? Well, it's got 4 key components. First, a constitution. Think of these as the hard-coded, non-negotiable rules, the stuff an AI can never do. Second, an accountability mechanism, basically a cryptographic digital DNA, so you can trace every single action back to its source. You know who's responsible. Third, a human-led command center to set the big picture goals. And fourth, and this part is just genius, an immune system. It's an AI red team that uses the exact same digital twin to constantly attack its own system to find all the vulnerabilities and fix them before they ever see the light of day.
So you see the key here, right? The digital twin is the linchpin for this entire vision. It is both the ultimate training ground for building capability, and it's the ultimate virtual sandbox for testing for safety. It's where we build the power, and it's also where we instill the wisdom. It's where the engine gets its compass.
Look, what NVIDIA is doing here is building the muscles and bones of physical AI. It's an incredible engineering achievement. This double helix model gives us a blueprint for its moral compass, for the nervous system that's needed to guide it. But that still leaves one huge, critical question on the table, a question for all of us, really. As we stand here building the most powerful tools in human history, how do we make absolutely sure they serve all of us?